Hello everyone. The following topic is about important organ, the liver. Firstly, let's review a well-known Greek story. Because of stealing fire for human beings, Prometheus was chained on the cliff of the Caucasus Mountains by Zeus. Every morning, an eagle was sent to eat his liver. However, his liver grew back at night. It's a myth that the liver could grow overnight. Well, it's a fact that the liver has great potential to regenerate. In animal experiment, after 70% of the rat's liver was removed, the liver grew back to its normal size in about 20 days. Similarly, in human liver transplantation, liver regeneration was assessed by magnetic resonance imaging (MRI) in living donors and the recipient. The results indicated that human liver regeneration is also very rapid. Why does the liver have such a strong proliferation ability? At the end of this session, you should be able to describe the structures and functions of liver, list the composition of hepatic lobules and portal triad, and relate this to some relevant clinical phenomena. The liver sits on the top right side of the belly, has two large sections called the right and the left lobes. The gallbladder has the liver. The functions of liver include several aspects. First is the secretion and delivery of the bile to the duodenum for digestion. Secondly, it takes part in metabolism of nutrition, including lipid, carbohydrate, and protein. It's the site for detoxification of some harmful substances and drugs. During fetal stage, liver is also an organ for hematopoiesis. Under light microscope, it's easy to identify that the structures of the liver, which is covered by connective tissue that form the capsule. Connective tissues also extend deeply into the organ to divide it into typical hepatic lobules. The histology of hepatic lobules is different from the anatomy lobes of the liver. Lobules are the smaller divisions of the lobes. The lobules are polyhedral structures with a diameter of 1 to 2 millimeters. They form the building blocks of the liver, consisting of hepatocytes arranged in place between capillary network sinusoid and a central vein. They are the basic structural and functional unit of the liver. Between the hepatic lobules is the portal area, with connective tissue and the portal triad. The portal triad has the branch of the hepatic artery, a branch of the portal vein, and a small bile duct. The bile duct in portal area is lined by simple cuboid epithelium, which carries bile products away from the hepatocytes to the large ducts and gallbladder. Bile can be stored in the gallbladder and discharged into the small intestine through the ampulla of water. The function of bile is to help lipid digestion. Patients with hepatitis have reduced bile secretion, often associated with digestive disorders, such as decreased appetite, nausea, and vomiting. Branches of the hepatic artery carry oxygenated blood to the hepatocyte. The lumen of the arteriole is small and regular. The diameter is similar to the bile duct, while the wall is composed of several layers of smooth muscles in addition to the innermost endothelium. Branches of the portal vein in the portal tract have big and irregular lumens and a relatively thin wall. One end of the portal vein is the superior mesenteric vein, which collects the substances absorbed by the GI tract, while the other end branches out in the liver. Blood from the branches of the portal vein and the branches of the hepatic artery form the sinusoid between hepatic plate within the hepatic lobules. Within the sinusoid, specialized stellate macrophages called Kupffer cells are there to phagocytose aged erythrocytes and bacteria, thus helping to filter and clean the blood. The blood always flows from the periphery through hepatic sinusoid to the center vein in each lobule. Consequently, oxygen and metabolites, as well as other toxic or non-toxic substances absorbed in the intestines, reach the lobules periphery cells before the more center cells. The main components of the hepatic lobules, the hepatocytes, are the real site for metabolism. Hepatocytes adhere to each other firmly with desmosomes and junctional complexes that form the hepatic plate. Between the lateral hepatic plate are the hepatic sinusoid. Hepatocytes are large polygonal cells with large nuclei and eosinophilic cytoplasm, rich with organelles. The cells are frequently binucleated, which indicates active cell proliferation. This diagram shows the organelles in the cytoplasm of hepatocyte. There is a great deal of rough endoplasmic reticulum for protein and smooth endoplasmic reticulum for lipid metabolism, as well as biosynthesis. Glucose is stored in the glycogen granules. Most of the material for metabolism are taken up from the perisinusoidal space for processing and will be released back to the same space. Bile will be secreted into the bile canaliculi, which flows from the center to the periphery of the lobules and from the bile duct in the portal area. There are foreign and sometimes harmful materials that need to be metabolized or detoxified by the hepatocytes. For example, alcohol and therapeutic medications. The detoxification process of these materials may also be harmful and may result in the necrosis of hepatocytes. To sustain the overall function of the liver, the hepatocytes are active in proliferation for cellular repair and functional recovery. That's why we can see the binucleated liver cells under the microscope. Now, let's summarize. Division and proliferation are responses of hepatocytes to injuries and also the basis for the repair of promiscuous liver. Due to the active regeneration of hepatocytes, unlike other organ transplants, reduced size liver can be used in living donor transplantation. Here are the references. Thank you. See you next time.